Hey everyone and welcome back to the channel. If you are preparing for coding interview, there's one problem you are almost guaranteed to come across. The two-sum problem from LeetCode. It's a classic for a reason. It tests it tests your understanding of basic algorithm and data structures. In this video, we are going to do a deep dive into this problem. We will start by breaking down what the problem is asking. Then we will go through two different ways to solve it. The straightforward brute force method and the much faster optimal solution. So whether you are a beginner or just need a refresher, this video is for you. Let's get started. First thing first, let's head over to LeetCode and look at the problem statement. The problem says, given an array of integers num and an integer target, return indices of the two numbers such that they add up to target. It also mentions a few important things. You may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. So let's break this down with an example. Imagine we have this array uh, 2, 7, 11, 15, right? And our target is 9. Our goal is to find two numbers in this array that add up to 9. If we look at the array, we can see that 2 plus 7 equals 9. So the answer would be the indices of these two numbers. In this case, 2 is at 0 index and 7 is at 1 index. So the output should be like this, 0, 1. Simple enough, right? Now let's think about how we can solve this with the code. The most straightforward way to solve this is with a brute force approach. This means we will check every possible pair of number in the array to see if they add up to our target. How would we do that? We can use two nested loops. The outer loop will pick a number and the inner loop will go through the rest of the numbers in the array to see if it can find a pair that sums up to the target. Okay, so let me write the code first. Let me run this solution. Accepted, submit, accepted. All right. So let's walk through this code with our example. Num is equal to 2, 7, 11, 5 and our target is 9. So the outer loop starts with I is equal to 0. So num of I is 2, right? And the inner loop starts with I plus 1 and it will go till length of like numbers. So the num of j is 7, right? Then here we are checking that if num of I plus num of j makes our target or not. So for this, yes it is. So we return the indices of I comma j which are 0 comma 1 and we are done, right? So this approach works, but it's not the most efficient. This think about the time complexity. For each element in the array we are iterating through the rest of the array. This means for an array of size n we are doing roughly n cross n operations. This gives us a time complexity of O of n square, which can be slow for large arrays. So how can we do better? We can optimize our code by using a hash map, or we can say dictionary in Python. A hash map is a data structure that allows for very fast lookup. So the idea is to iterate through the array just once. For each number, we will calculate the complement. The other number we would need to find to reach our target. Then we will check if that complement is already in our hash map or not. So for that, let me write the solution first. So here I'm going to create a hash map to store nums and their indices. So let me run this solution. Okay, so accepted. All right, so this solution got accepted and all the test cases are passed, and like we have beat the 100%. So let's trace our code with the with our example. Let's say let's again take the same array 2 7 11 5, and target is equal to 9. So we will start with an empty hash map num map. Then on like first iteration, num is equal to 2 and I is equal to 0, like indices and value, right? So the complement is equal to 9 minus 2, right? So is 7 is in our num map? No, it's empty. So we add 2 and its indices 0 to our map. So num's map is equal to, it will be like this. Num map will be like this, right? uh, After first iteration, on second iteration, num will become 7 and I will become 1, and the complement is 9 minus 7, which is 2. So is 2 in our hash map, like in our map? Yes, it is. So this means we have find our pair, and we return the indices of the complement from the map, and like which is 0, and the current index I, which is 1. So the result is 0 comma 1. With this approach, we only have to go through the array once the lookup time is hash map is on average constant time. This makes our overall time complexity O of n, which is huge improvement over the brute force method. So there you have it. We have solved the two sum problem in two different ways. We started with the simple brute force approach and then move on to the more efficient optimal solution using a hash map. Understanding the trade-off between different solution is a key skill in software development, and sometimes that interviewers are always looking for. I hope you find this video helpful. If you did, please give it a thumbs up and don't forget to subscribe for more content like this. Let me know in the comments if you have any questions or what other problems you would like to see me cover. Thanks for watching and happy coding.